Okay, so what we're going to say is a number of strange things going to look like this. First of all, we can say overdraft, overdraw, I guess we can overdraw. We want to create overdraw exception class, and we will declare that this method could produce the exception. It's almost like if you try to execute a formula, and if you try to divide by 0, it's not going to be executed for you. Instead, your program may actually crash. If no one takes care of the attempt to divide by 0, CPU produces the exception, and the program may crash. In our case, we want to completely stop doing what we're doing and try to alternate things in our application. We want to be able to, we want to say that this particular method withdraw can throw an exception. There is a keyword that stands for this, and we will talk about the two possibilities, really, how you can work with exceptions, how you handle them. And one of the possibilities to say that this particular method will be designed so it throws an exception. In particular, what we're going to do is, now here's something else to mention here. If withdraw fails because the user specified an overdraw amount, if this fails, we don't even want to produce this transaction ID. There is no transaction. The transaction will be rolled back completely. The transaction there should be no transaction at all. There will be a condition saying it's impossible. Such transaction is impossible. So it's very interesting that what we're going to do is this. We can just say if the balance, I guess we can, if the balance is less than the attempted withdrawal amount, right? Then what we're going to do is that we're going to throw, this is how exceptions are generated. They're thrown. We still have to create an object, and this will be our object. Overdraw exception, that's what I call it, overdraw exception. And we can basically describe the situation by saying overdraw. Overdraw, that's the exception. And we can specify by how much, right? So we can take the balance, and subtract the amount that they try to withdraw. So we're going to show them, minus $100. That's the overdraw. That's by how much, something like this. So this is the syntax. What's missing is the definition of the overdraw exception. Now notice this. The first step is to say that the method could potentially throw an exception. So when it's compiled, special care will be taken of the program stack, which will be organized for us by the runtime environment. And the overdraw exception it can potentially entirely alter the case of execution inside this method. For example, if the balance is not less than the amount, so this is still possible, then we're going to do the normal thing. Otherwise, notice this, there is really no return statement. We promise to the user that, hey, withdraw method returns a long integer, right? Which in our case, what we return at the end is this transaction ID. In case of an exception, and we want this to handle at the level of an exception, that is just absolutely impossible to deal with, is that we, instead of saying return, we're using a statement, the throw statement. The throw statement simply takes an instance of an exception class, which we're yet to create. I named it Overdraw exception. All right? But because we still have to create this class and populate it with information as we want to, right? We must say new. So all these things come with some of this territory. So let's go ahead and create this exception class. Control C, that's the name of the class that will be representing our exceptional situation in our application. And it will simply be added as another class to our package inside of our application right here. So new Java class, and we can say that this is an overdraw exception. Finish. So it appears to be just a regular class, right? But what we're going to do is that we're going to use the base for our exception class is going to be one of the I'll just say exception. One of the Java language package classes, which is an exception. This is the parent of all exceptions in Java. All other types of exception in Java derive from the exception class. So when you design this to be able to say throw right here, right? To be able to say in our account class, to be able to throw it, it's quite a possibility for us to do something like this. We need to define our overdraw exception as the class which is in itself deriving from the exception class. So when we say extend, remember the extends keyword in Java is that inheritance relationship in UML. So this particular class only needs a constructor to begin with. So public. Let me take a look what else I claimed for that particular class. Overdraw. We can say in the overdraw exception. So first of all, the error condition that we're trying to handle with this exception class is going to require to provide string a message, like describing what is going on, and then also a double amount, which is the by how much amount right here. And what we're going to do here is that we need to maintain those data attributes. So we can say string message and string amount will be the attributes stored by the object. Will be stored by the object, and then they're going to be initialized right here. Message and amount, and then of course there's this pointer which disambiguates those two data attributes. With one little trick, because we're deriving from the exception, we also want to be able to construct the parent class, which will be part of this exception when it's instantiated. We need to call it Superclass Constructor. Superclass Constructor is invoked through the superclass, and the exception class uses a string. One of the constructors takes the string so that it also is properly initialized. So we'll talk specifically about those little details later on. So far I'm just trying to demonstrate what it takes really to create this simplest exception class that we can use, define it ourselves, and use it as an exceptional situation in the code someplace else. So now this part is hopefully this is organized. Now, since I'm just thinking, since string and double, let's call them private, just to keep them explicitly private. I need both to say there's a string get message, get error message, right? Which simply another public method, and it returns the message that we store, and also another very similar method which will return a double amount. So get amount, right here, a return amount. Okay, so perhaps this is the design that we need. So what happens now is that this code now complete. We just say, well, you know what? If this happens, if this condition becomes true, we're no longer going to do our transaction. Instead, we're going to throw an exception. An exception, as you can see, there's really nothing fancy about it. It's just a class that has a constructor. By the rules of Java, it's it needs to derive from one of the existing exception classes. One of the typical superclass options here is the exception class from the Java language class package, and you define the constructor, make sure that the superclass is constructed properly, store the message, store the amount, which is very important for us, right? Because once this particular exception is created, we also need to remember some useful information about what's going on. And then it gets thrown. So we try to call all of this from our customer class. In the customer class, which says process transaction, we just said withdraw. Well, in case when, oh, let me see, this again is